Hey guys, welcome back everybody. In this today's educational video on brilliant.org as usual, yes, I'm going to work out some level review questions like in this tab here in the chapter called Programming with Functions level. Actually, it should be level 2, not level 3. You're about to level up, right? Something I'm quite excited to do some level review like part of a recap that I previously discussed in my previous videos. Wait, just ignore all these contents on the left because they are not necessary to explain anymore. So this level review, right, with this icon, right, I'll click the start button to begin the lesson review for today. Here we go. Wait a moment to get these contents loaded. You just wait a little more further. Sorry, connection is a little too slow. All right. Anyway, here we are. Right, this is kind of first problem. Question number 1. Analyze the program. What's the value of pixel once the program finishes running? Okay, let's read it out. Only red pixels are RGB. Color right. Only red. RGB. Only R will return this 50, the rest is 0. So I think this one will be the new output value, right? Let's check. That is simply correct. Why? The explanation tells us that the program first initially creates the pixel variable and sets it to bracket 50, 150, 0 as shown in line 1. Then it inputs pixel 50, 150, 0 to the only dash red function. Output of 50, 0, 0 that shown in line 6 becomes pixel new value as shown in line 2. Take this line 2, then return only 50, then the rest are 0 values. The output will execute as appropriate, right? Something simple to get started. Anyway, continue to the next. This is question number 2. Again, analyze the program. New value of pixel once it finishes running. Okay, let's see. 50, 150, 0. Only yellow pixel, right? Return only last is 0, so it should return the same value, isn't it? Because return this one like in the previous problem. Let's check. Of course, it's correct. Why? The explanation tells us here the program first creates the pixel variable and sets it to bracket 50, 150, 0, close bracket as shown in line 1. Then it inputs pixel this only dash yellow function. Finally, the output being bracket 50, 150, 0, close bracket. Therefore becomes pixel's new variable from that line 2 as required in line 6 that return will execute appropriately, right? No time to waste anyway, continue to the next. This is question number 3. Complete the function. Make the function erase red pixels by turning them black. Oh wait, that's interesting. Wait, I need to scroll down, I think. Like this. For pixel and image, erase red pixel, erase close dash color RGB. So this red pixels to be replaced by black, so like this. What should be red to black if I think this comes first. Red outnumbers others, then it should be replaced by black, I think. 3 zeros, right? Red more than green and blue, else the RGB, right? It should execute correctly, I think. Let's check it now, shall we? You wait why this program is going to loop. Wait a second after it completes. This is truly correct. Why? That's right. Explanation tells us that a red pixel will have R, which is greater than both G and B. So if R greater than G and R greater than B should satisfy both conditions. For these inputs, line 6 returns a black pixel. Yeah. Both conditions met in line 5, then all triple zeros will return line 6, so all black. Red turns to black, right? I close that. All of those previous red coordinates have turned to black, so mine is correct. Anyway, continue. Question number 4, I think. Update the function. Instead of erasing red pixels, make the function erase blue pixels by turning them black. Slightly different. Previously, red to black, now blue to black. Output black remains unchanged, so need to update slightly different. Blue means so this one. Blue greater than red and green, so this one should be correctly executed. Time to check now. Wait a moment for it to finish executing it. Oh yes, this is correct. Why? That's right. A blue pixel will have B greater than both R and G, as I previously mentioned in line 5 as shown. For these inputs, subsequent line 6 returns a black pixel, again as required, triple zeros, all black, 100% black to be honest. Let's move on and click continue. This is question number 5, I reckon. Write the patina function. Return a new color where green is a mixed value and red and blue are 80% of green. Okay, these inputs are given like this. We need to read the output. Oh yeah, new color, green, mixed value. Let's see. RGB is color. 80% of green. Green are mixed value. This mixed value is, I think, new G, both new R, new B is 80% of green, right? And RGB will be in this order like this as required. Time to check it. Almost. Oh yes, this is luckily correct. Why? That's right. Explanation simply tells that on line 2 here, function unpacks the input color tuple into 3 variables R, G, and B, storing the amount of red, green, and blue as shown. Then on line 3 here, sets the local variable new G to a green heavy mix of the original color. So green compound being greater than red and blue, that is already given. Next, on lines 4 and 5, sets the local variables new R and new B to 80% of the new G value. So right, both have to be 80% proportion of green. Apply to both lines 4 and 5 as appropriate. Finally, on line 6, function returns a new color tuple that new dash R, new dash G, and new dash B. Same RGB order in sequence. It should be correct as I just displayed to you. Anyway, move on and click continue. This is question number 6. Complete the program. Use the patina function to filter the image. The previous patina function, let's see how we should execute this one. These two, yes. Picture on image, yes. Lines 4 and 8 already given, so doesn't need to change. Patina and pixel should be in the brackets. That should execute properly. Press check now. Oh yes, that's correct. Why? That's right. The explanation here tells us that this program loops through every pixel in the image. As it loops, it changes the value of every colored pixel to the output of the patina function. Yes. Lines 1 to 8 here, I only had to insert line 2 as required like this. That's only correct way to figure out the program. So just part of basic problem that I have to encounter, but simply okay though. I'll just click continue here. This is question number 7. Analyze the program. What's the value of pixel when the program finishes? Wait, need to invert blue, so let's see. RGB color will be the same. Invert blue, wait, minus B. B inverse, right? So only B is different. So first was 0, 255, new one will execute, right? Let's check it. Oh yes, likely correct. Why? That's right. Explanation here shows that line 2 passes triple zeros to the invert dash blue function, and then line 5 assigns 255 or 255 to B dash inverse, which being take away 0 remains 255 value, so line 6 returns that RNG 0, that new B is 255, right, as required. Appropriately required, I mean. Continue. Question number 8. Complete the program. Use the function to invert the blue channel of each pixel. That's right, like in the previous problem, like you notice these lines are already given correctly, so just modify this line, single line to get this program running properly. Should be like for pixel image, invert blue should be first, pixel should be in the bracket. Right. Check it now. Wait a moment. It is correct. Why? The explanation tells us that line 1 loops over every pixel in the image, so 4 pixels. For each pixel, line 2 call the invert dash blue function to invert the blue part of each pixel. So invert blue, only these blue layers are affected, so that return B dash inverse as required. I only added line 2, like it should be this way. It should execute correctly and appropriately that you just discovered with me, right? So this final output, look at it, an almost completely bluish background. What do you think? Let me know in the comments too, if you wish to, right? Anyway, continue. Here's question number 9. Plan the function. A magenta/green duotone filter sets both red and blue to the mixed brightness level. What should the green channel be? Oh wait, let's see. Green magenta duotone filter. Pixel means a mix, like should be like this. Mix inverse 255 minus mix. Green channel. It shouldn't be 0, no mix. Lighter are magenta, so darker green, right? I reckon it must be mix inverse. Not mix, cause like green is like darker tones, so like darker tones are more greenish. That should be correct. Let's check. Of course it's correct, luckily. Why? That's right. Darker colors have a lower mix and higher being mix dash inverse. Right, explanation here. Since the darker colors should be greener, line 5 sets the green channel to mix dash inverse. That's appropriate here. That's right, mix dash inverse darker tones to be more greenish parts of the background. Luckily, I solved this like correct, only like considering for a matter of seconds, then had to figure out this explanation briefly as required. I've just explained to all of you. Continue, I think the last question left to encounter in this level review. Yes, last but not least, this should be question number 10. Complete the function. Make the brighter colors more magenta, which equal parts of red and blue applied, and the darker colors more green. Just complete this part. I think so. Wait. Equal parts of red and blue. That's already given the explanation, so shouldn't waste any more time to figure this out. I'm not going to read out these lines 1 to 6, so equal parts red and blue should be mixed. Mixed inverse, only green is at the center, right? It should execute properly. Let's check it now. Wait a moment for the image to finish applying it. Wait. Sorry, like, it's taking a little too long. Wait. Just a few seconds more left. Don't worry, everybody. Oh yes, truly correct as I expected. Why? That's right. Explanation here tells us to make brighter colors, more magenta, line 7 should set both red and blue to mix. This formula will execute in as in line 5. Map darker color towards green, it would set green to mix dash inverse as inverse line has been applied in line 6. So this is the return final output as appropriate. If I close it, this final background has been correctly applied, right? Today, my level 2 level review for this kind of programming with functions chapter has been successfully completed, like 10 out of 10 questions correctly. But sorry, this is taking a little too long. But anyway, I think it's time to finish off now and tell you more about what I would be doing next, like part of my activities. So I'll click finish for this session for today. Wait a moment. That's right, level complete. As a result of this, my programming with functions end of level review completion, like this is part of level 2. So what's the number here? I've gained 160 XP total experience points this time around. Wait, just look at this. And when the green icon turns around, I'll review the number. Yes, that's right, number 2. So level 2 has been completed. So stepping up to level 3. That's what I'm going to tell you later. Continue. That's right. As I'm showing you here, I'm still in the Einsteinium League after last season, retaining the class. So just join here. Keep earning XP to climb this week's leaderboard. Like, there are plenty of days left to learn from. 4 days left before overall week session has been concluded. Not going to repeat. Continue. That's right. As I want to scroll down, no. Here, level 2, end of level review. That's what I've just completed. Here, I scroll down, like level 3, debugging functions, kind of new chapter I've just stepped in. Tracing errors is the very first chapter. I gotta have to learn a lot from it, but not right now. Sorry. Anyway, that's the end of my today's educational video that I've presented. Thanks very much for watching from the start to the very end. If you do so enjoy watching, then don't forget to add a like and my subscribe button for more videos, as I'm showing you underneath right here, right? You choose left or right for my favorite videos and the corresponding educational video playlist, as well as subscribe button, this center logo that I've just displayed. But I'll still keep on try recording these more videos, and then you just stay tuned for more, like probably record a new one in the future, right? Anyway, I'm leaving this session for today, guys. It has been too late. Very tiring day, right? See you later, guys. Take care. Have a great day and bye for now.